Here we have photomorphogenesis in action. So I have a little makeshift experiment that I set up, and I germinated a couple of those pea seeds that we had, a couple that I had left over, and I set up two treatments, one there in the back where they were grown under full light conditions, and then this treatment in the front, if you can see it, that is grown under shade. And if you look, I'm going to remove this now, you could see that there are marked differences between these guys that were grown in the shade and these guys that you can't even see back there that were grown in the light. So I'm gonna remove this one and we'll look at these two. And I have some microgreens mixed in there just by accident. But these guys were planted at the same time, they germinated at the same time. So when I put that shade up, they were all the same, for the most part, the same height in terms of their stem. And you can see here the big difference that we see in the morphology of our plants that were grown in full sun. They are shorter, they're a little more branched out, they have darker leaves, as opposed to our plants that were grown in the shade, where they have longer stems, less branching, and less dark leaves, lighter color leaves, right? So that chlorophyll production isn't as prominent as it is over here, right? So that is an actual example that we've shown of photomorphogenesis. And if you guys recall, this is all related to that phytochrome pigment system, right? It has those two forms, phytochrome red that detects red light, and phytochrome far red that detects far red light. And under normal light conditions that we had over here, there's more red light than far red light. So that phytochrome red, when it detects that red light, it gets converted to phytochrome far red. And that phytochrome far red is an active, we call it an active version of the pigment. It interacts with transcription factors and it activates, turns on all these genes that make our plants grow like this, right? Branch out, it initiates more chlorophyll synthesis, as opposed to over here, where we were either in darkness and that phytochrome far red gets converted to red in darkness, or if some of the light was able to, I tried to get filters that would shade out the red light. I don't know, I just used random filters. But in that case, we are having in these plants more of a buildup of that phytochrome red, and that's that inactive version. So the transcription factors that would result in the growth of this aren't being active, so those genes are turned off, and instead we have this longer spindly growth. And this is a shade response. This is an adaptation to shade response, right? I had these filters set up like so, and it was blocking the light, and all the plant knows is that it's getting shaded out. So as a response to try and get above that shade, it's gonna grow tall and long. So there you go, just a quick little experiment to show photomorphogenesis in action.